Next, we're going to talk about empirical probability. Our empirical probability is the same as experimental probability, as we said in the first video. So if we go back here to the data that we collected in our initial class survey back at the beginning, it seems like a very long time ago, back in January. And I took the ages of all of the college students that you guys surveyed, and there were a total of 82 of them. Of those 82, they were all ages 17, 18, 19, 20, 21, 22, 23, 24, 27, or 53. Okay. I'm going to try to get my things to work correctly and get a picture of that. In a table. A lot of times when we're asked to do an experimental probability, then they give us our data in some sort of table form. Your author will usually make it horizontal because that takes up less space in the book. But here there were a total of 82 people surveyed that had data that we could actually work with. And so if from that list of 82 students, maybe I call them student 1 through student 82 or something, if I want to draw one of those students out of the list, out of the hat at random, and I want to know the probability that that student is 20 years old, then if I'm only drawing a single student and that's all we're going to be doing in this first section, then out of the 82 possible students I could choose from, looking at the table, the chart, it tells me 25 of them were age 20. If it says, what's the probability that that student is 18? Okay, then out of the 82 students that were surveyed, it looks like 14 of them were 18 years old. Now 25 over 82 did not reduce any farther, but of course 14 over 82 does. I get 7 over 41 for that probability. Maybe it says I want to know that the probability that that student was older than 21. Okay. Older than 21 means starting at 22. And so if we come back to the table, I've got these students here are the ones that are older than 21. And it looks like I have 1, 2, 3, 4, 5. So 5 of those students out of 82, which is in lowest terms. Okay. I want to know the probability that that student was 19 or younger. 19 or younger includes 19. Okay, maybe it has a less than or equal to sign if I'm, looking at a different situation where the table's presented maybe in a different way. Okay, 19 or younger means 19, 18, or 17. If we add these up, there's 46, 47. 47 of those students out of 82 was equal to, or were 19 or younger when they took this survey. And again, the only one that wasn't in lowest terms was this one up here. Okay, maybe I want to find the probability that the student was not 18. So we can talk complements here. Okay. Of course, one path I can take is if I want the students who are not 18, I could add up all of these numbers, and that wouldn't be horrifically long or drawn out to do that. My calculator could help me, and with all these ones, I could probably do it in my head. Okay, so actually let's do that real quick. So out of those 82 students, there's 33, 53, 58, 63, 64, 65, 66, 67, 68. 68 out of 82, which if I reduced it, it would be 34 out of 41. Okay. Or we said the probability that that student would be 18 is 14 out of 82, which is 7 out of 41. So if I want the probability that the student is not 18, I could take 1 minus the probability that the student is 18, or 1 minus 7 over 41. And if we take 41 over 41 minus 7 over 41, we get 34 out of 41. Okay. And either path, oops, I missed there. Either path that I take will get me to the same answer. And one wasn't necessarily any longer, shorter, or necessarily preferred in this particular situation. But again, there are situations where finding that complement is going to be a shorter or a smaller piece. And once I know that, then I can find the piece of the event that I'm after. Okay, well, I think, folks, that officially gets us through section 4.1. Now, 4.2 gets a little bit more exciting, and hopefully the tech will keep up with me so I can get some more videos posted there. Okay, let me know if you need something.